We have earlier studied Y parameters or conductance parameters of two port networks. Now, we will look at Z parameters. As I mentioned earlier, these are different descriptions of exactly the same thing, and it is like specifying either the conductance or the resistance of a resistor. Okay. And in case of Z parameters, let us say we have a two port. Naturally, this can contain all linear elements, but no independent sources. So, we think of currents as independent variables. You apply I 1 and I 2, okay, and you measure V 1 and V 2, and of course, V 1 and V 2 will be linear combination of the two independent sources which are in the circuit. V 1 will be Z 11 I 1 plus Z 12 I 2, V 2 will be Z 21 I 1 plus Z 22 I 2. Okay. As usual, mind the directions of voltages and currents. Okay. They follow the passive sign convention, and this is usually also represented in a matrix form. It is exactly the same thing. So, the linear equations are placed in a matrix form, that is all. Okay. And this matrix, this 2 by 2 matrix is known as the Z matrix or Z parameter matrix of the 2 port. Okay. So, the definition is similar to the Y parameters, except that here currents are independent variables and voltages are the dependent variables. Okay. Now, if you compare this to Y parameters, what did we have? In case of Y parameters, we had I 1, I 2 to be equal to Y 11, Y 12, Y 21, Y 22 times V 1 and V 2. Now, clearly looking at this and that, you realize that the Y matrix is the inverse of the Z matrix. Okay. So, Y is the inverse of Z, or Z is the inverse of Y. Okay. Now, it is possible that one or the other of these is not invertible. Okay. Perhaps the Z matrix is not invertible or the Y matrix is not invertible, in which case you can't define the other one. Okay. So, that is always possible, and this is equivalent to having, let us say, a short circuit which can be specified as 0 resistance, but you can't specify its conductance, it is infinite. Okay. So, it is similar to that. We will see examples of this later. Okay. Now, let us say you are given a network and you are asked to find the Z parameters. You need 4 measurements, because you have 4 parameters, and by taking 4 possible combinations of I 1 and I 2, you will get 4 equations, right. You take 4 possible combinations of I 1 and I 2, measure V 1 and V 2 for each case, you will get 4 equations, and that is it. From that you can solve for the 4 parameters. Okay. Now, the convenient combinations to take are, first of all, you set I 2 equals 0, that is your open circuit port number 2. Okay. So, under those conditions, what happens? You will get V 1 to be Z 11 I 1 and V 2 to be Z 21 I 1. Okay. In other words, you leave the second port open and you apply current I 1 to the first port and you measure both V 1 and V 2. Okay. So, from that we easily see that Z 11 is V 1 by I 1 with I 2 set to 0. Okay. And similarly, Z 21 is V 2 by I 1 with I 2 set to 0. Now, because you make these measurements with the second port open circuited, the Z parameters are also known as open circuit parameters. Okay. So, you set I 2 equal to 0. So, only one of the independent sources comes into play, that is all that is there to it. Okay. Like I said, you could take different combinations of I 1 and I 2, but this is the most convenient. So, you have Z 11 and Z 21. Z 11 you can see is nothing but the resistance looking into port 1 with port 2 open circuited. Okay. And Z 21 is the trans resistance from port 1 to port 2 with port 2 open circuited. Okay. Trans resistance means that it is the ratio of voltage to current. So, it has dimensions of resistance, but the voltage and current are not measured at the same place. Okay. The current is applied to port 1 and the voltage is measured at port 2. Okay. So, the principles are exactly the same as with Y parameters. So, I will go quickly through these remaining parameters. In case of Y parameters, we short circuited one port and measured 2 parameters, then short circuited the first port and measured the other 2 parameters. Here, instead of short circuiting, we are open circuiting, okay, because here the independent variables are currents. We set current to 0, that means a port becomes an open circuit. Okay. Port is open circuited. So, measuring the other 2 is quite simple. For measuring Z 12 and Z 22, open circuit port number 1, that is you do not connect anything to port 1, you connect I 2 to port 2 and measure both V 2 and V 1. Okay. So, the first equation reduces to V 1 equals Z 12 I 2, because Z 11 I 1 is 0, because I 1 is 0, and V 2 will be Z 22 I 2. So, from these we get Z 12 to be V 1 by I 2 with I 1 set to 0, that is port 1 open circuited, and Z 22 is V 2 by I 2 with I 1 set to 0. Okay. That is Z 22 is the resistance looking into port 2 with port 1 open circuited, and Z 12 is the trans resistance from port 2 to port 1 with port 1 open circuited. Okay. So, these are pretty simple definitions similar to Y parameters. It should be pretty clear.